Okay, so we went back to this one problem in 4.1, which was an inequality, and we need a sign chart for it. So those are pretty new for us, like brand new this year. So looking at 62, it says x squared minus x minus 6 is less than or equal to 0. Okay, those are even better. So what are we doing here? We're trying to figure out where the graph is less than 0, which means the graph is under the x-axis. And we said we could prove it with a sign chart because that means that the graph has to be, or the numbers have to be negative, right? If it's going to be under the x-axis or less than 0. So this, if we just write it out, we can figure that out. But we need to find where it is 0. You're good? Okay, cool. So if I factor this into x and then minus 3 plus 2, that looks terrible. Then I get x squared plus 2x minus 3x and then minus 6, and that works. Okay, so if these are my factors, x minus 3 and x plus 2, and I set this equal to 0 to find these values that are equal to 0, one of them is going to be negative 2, that goes here, and one of them is positive 3. So it is important that you put them in the right order because then you're getting the right intervals. So what I'm going to do is I'm going to check. I've got an interval that goes here from negative infinity to negative 2, and then between these guys, and then after 3. So these are the 3 intervals I'm checking with my sign chart. And if I get a negative value, then I'll circle it, and if I get a positive value, I'm going to cross it out. So if I plug in negative 3 here, I'm going to get negative and then negative. So this value is positive, and that's good. If I plug in 0 here, is that what you would choose? Okay. 0 minus 3 is negative. 0 plus 2 is positive. If I multiply those two values, I get a negative. So that's not, oh, shoot, I did this backwards, didn't I? I did this whole thing backwards. This one's bad. I'm supposed to be looking for negative numbers. I made all that work, and I'm really looking for negative numbers. So this one's not good. I was supposed to find graph under the x-axis less than 0. I'm looking for negatives. So this positive is bad. This negative is good. And then 3, I'm going to try 4 because that's between 3 and infinity. 4 minus 3 is positive. 4 plus 2 is 6. That's positive. This is positive, so that's bad. So this asked me a backwards question. I needed the negative values.
Wait, would the graph be like a parabola?
So the graph is a parabola. It actually looks like, so negative 2 and positive 3. It has some vertex here in the middle. And this is positive and this is positive. But I'm looking for the negative. That's what I want. So I want between negative 2 and 3, and I want to include the endpoints because it says equal 0. So that means these zeros are included because they're 0. So sign chart. I could do it without the graph, but it is nice to sort of look at it and go, oh yeah, that's what it looks like. So that was 62. So in 4.2, we had several problems, but these are the even answers. So pause the video and check your even answers. What ones? Okay, so we're going through number 4, and the problem had this on the bottom. This is what you're dividing by, so it's what goes on the outside. It's also got the smaller degree, so you want to divide this one into this one. Jack, put your phone away. Thank you. We need a 7 and an x cubed, because now if we multiply back, we get 7 and x to the 5th. So 7x to the 5th, and then we multiply this by 1, and we need to line it up in the right spot. So we need to take this one and multiply it by 1, but we need to put it here because it's got a cube on it. So we're thinking about organization with this type of problem. So that now when I draw a line and change the signs, when I add down, the things that go together are together. The first one cancels. Nothing went with negative x to the fourth, so I'm just going to leave it as negative x to the fourth. 2 minus 7 is negative 5x cubed, and we bring down, and that's all 4 steps. Divide, multiply, change the signs, and bring down. That's 4 steps. Repeat. Do it again. X squared times negative 1 would give us the negative 1 coefficient, and I need x squared. And that looks like a different number because I wrote it real weird. And then multiply back. So these two together, x to the fourth, negative x to the fourth. These two together go here, negative x squared. I want to line things up that go together. So long division is a lot about being organized. And there we go. So now we draw a line. That's a reminder to change the signs. If we didn't change the signs, this guy wouldn't cancel. We need to be minus 1 and plus 1, so they cancel. Now when we add negative 5x cubed, we got nothing to add it to, so we just write it down. These two together cancel, don't they? So they're gone. So now x times what makes negative 5x cubed? Negative 5 and one more x. Multiply it back through. Negative 5x times x squared, negative 5x cubed. Negative 5 times 1, sorry, negative 5x times 1 is negative 5x. Draw your line, change the signs, and then these cancel, as they should. This one doesn't have anything to add to, so we just get 5x. But x squared doesn't go into 5x. We need it to be at least the same degree for it to go into it. So, because this is bigger than this number. So this is a remainder. We can write remainder here. That will help us remember to write it as a fraction. So we're going to put 5x and then x squared plus 1, whatever you're dividing by, on the bottom. And then we don't rewrite it again because we're lazy, and we just put a big box around that up there, and we're done. It looks really difficult. If you showed this to a 5th grader, they'd be like, nope, can't do it. If they could do long division with numbers, and it would have just this many steps, it just wouldn't look so long. It might look long this way, but not so wide, I guess. So 4. Is that better? Is it the skipping part that was bad?
Yes.
Okay. So we want to make sure when we write this up here that we leave a space for every degree. And that way we have a place to line it up. Sometimes we might not use that space. But like in this case, we skipped a hole here. It just made it more organized if we wrote it out long and pretty. And then organized our stuff. Okay, 4. Next on our list is 16. Well, there we go. Okay, 16. X cubed minus 2x goes into 5. X to the 5th. Half of the battle is just writing this problem down because it's so long. And this one's nice because it goes 5th, 4th, 3rd, 2nd, 1st degree. I have all the degrees listed. It's really messy, but I've got everything listed. Do I have all the degrees right here? I could put a 0 here, but how about, because the problem's already so long, how about if when I write it here, I'm just okay with the part where I skip something, where I might need to organize it. Okay? All right. So x cubed goes into this. I need 5 and 2 more x's. So the division part, everybody good there? You're okay with just dividing by this first one? Okay. Multiply back out by everything, 5x to the 5th. And then here, 10, negative 10. And then x cubed in a line. When you draw the line, that reminds you to put negatives or change the signs everywhere so that this will cancel. Really, if it doesn't cancel, you know you didn't change the signs, or you just divided badly. Add these together. 1 plus 10 Did I line that up? Oh, bad. Miss Hate. Fix it. Javier, is that what you're going to say? Fix it?
Yeah, but
10x squared plus. What?
no, we're gonna say that.
So I said that before and then I went and forgot it. So just because I wrote it under here didn't mean I could add them together. They have to be, I still can't write it, can I? Okay, let's just do the second part over and I'll make it pretty. 5 times this first one, 5x to the 5th, minus, and it should go here, minus 10x cubed. Skip that one. Draw my line, change my signs. Okay, now I have the right degree and the right plus or minuses. Sorry about that. Add them together, negative 13 plus 10. Can I do this or do I need to remember this one? Like this one canceled, then the next one should be this one. 1 plus 0 is just 1, x to the 4th. Now put these together, 10 minus 13, that's negative 3x cubed. And then we bring down, write the rest of the stuff so we don't forget it later. Now I'm not going to make the same mistake again. When I multiply out, I'm going to skip something. X cubed goes into x to the 4th. Ooh, that's a good one. Just x times. That'll be x to the 4th. And then minus 2x squared. 1 times negative 2 is negative 2. X times x is x squared. Okay, so I'm doing better. Change the signs. This one cancels. Negative 3 plus 0 is just itself. These cancel. And then bring down 6x. Can I divide these again or am I done? One more time because they're the same degree. So I could multiply this one by negative 3 and have something that works. So when you get to the constant up here, that's your last time that you're dividing. So negative 3 times the first one is negative 3x cubed. Negative 3 times negative 2x is positive 6. So together they're positive 6 and x. So positive 6x. Draw my line, change the signs. This cancels and this cancels. So I have 0 remainder. There, 16. You have to look closely and then catch if you write something in the wrong place or whatever. And then because I was afraid that I had goofed up the problem, I just erased it and started that line over again. Sometimes that's what it takes. 22. Okay, 22 is kind of a different idea. It tells you that you have this polynomial p of x, and it's a long one. It says 32 x to the 5th minus 80 x to the 4th, 80 x cubed minus 40 x squared plus 10x plus 2. And what they've told us by this little k equals 1/2 is they've told us that if you put 1/2 into all of these places, you can find out what the value of p is. So p of 1/2 equals, and this is what we're looking for. But that's really hard. So instead, what's cool about synthetic division is that if you use this, because it's just one number, in synthetic division, whatever you get as your last number, the remainder, that's the same value as if you'd plugged it in. Because I don't really want to take 1/2 to the 5th power, because that would be 1 over 32, and that would cancel. That would be nice. But raising fractions to powers, that's not any fun at all. Doing this with a fraction may not be that fun, but look and see, I think it won't be that bad. So I'm going to write all of the coefficients down, 32, negative 80, positive 80, negative 40, positive 10, and 2. And my goal is to see what the remainder is. So the very first thing in synthetic division is to start with the 32. When I multiply, what do I get? 16. Subtract these two guys, so that's not 74, it's 64. Negative 64. Times a half, so 32, negative 32. Okay, I'm going to pause. Am I going too fast? Okay. 80 minus 30 would have been 50, so this must be 48. And it's positive. Half of 48. 24. 24 and negative 40, so that's 16. And it's negative 16. Half of negative 16 is negative 8. 10 minus 8 is 2. 1/2 of 2. 1. 2 plus 1 is 3. 22. Did I even write 22 down? Well, I guess I did. So this remainder is the same thing as if you'd have said 32 times 1 over 2 to the 5th power minus 80 times 1 over 2 to the 4th power. Like that's a lot. But synthetic division is just so quick and easy, even though it's a fraction, because they were such big, even numbers that it worked out to be really easy to do. So don't be scared of the fractions. A lot of the times it works out. Like it's not that bad. So the remainder is the same as if you'd plugged it in. Remainder number is the output of substitution. Does that make sense? If I had substituted it, substitution. If I had substituted it in, I would have had to do all this math and add it up. But instead, I just had to take these numbers and add them up. They were pretty simple. So that's what 22 was about. And then 41, right? Is that what else we're doing? 41. So from 41 was all about synthetic division. And so, actually it doesn't, oh, it does say use synthetic division. Okay, I lied. So I'm going to do x cubed plus x squared minus 18x plus 9 divided by x plus 5. The trickiest part about synthetic division for me is figuring out not the part that I put in the box, because that's easy. As long as we have 3, 2, 1, and 0 exponents, I can just write down the coefficients. 1, 1, negative 18, 9. So that part is easy. But for me, the hardest part is, do I use 5 here or negative 5? And the way I want you to think about it is, if you would put this in parentheses, you would use opposite math to get the number out that you put here. So when it's written in factored form, what you're going to put here is opposite math. Okay? So if you can remember that little tidbit, and so we've used that for everything. We've used it for translations. Over and over, we use that opposite math deal here. So if you can do the setup, then it's just even easier than that fraction one. It was just probably whether you use positive or negative 5. So here we go. Start with the first number, then we multiply, add, multiply, and then add 2, multiply, we get negative 1. This is the remainder, and then what do you do with it? That's the question. So in order to get these 4 numbers, I stripped away the x's. We've got to put the x's back here. This is a fraction, negative 1 over x plus 5, just like with long division. So the remainder is the last one. If you don't get 0, you have to make a fraction out of it. Then the first term here is a constant. This one is x, and this one is x squared. So they go up as you move this way, just like this one does. But note that this x cubed is smaller. Now it's x squared. When you divide, it becomes a smaller number. So this one's x squared. So my final answer looks like x squared minus 4x plus 2 plus whatever I got for my fraction. So 2 things to remember. If it's written as x plus 5, you use opposite math. So you're going to use -5. And then once you get the hang of doing synthetic division, it's just a matter of computation and then put it back into the right form. Other questions from last night's homework? All right. So moving on to 4.3, we're still using synthetic division here a lot. We may use long division, but more than that, we'll use synthetic division. What we're going to try to do when we find real zeros, we've done this before, we're trying to factor it. Our goal has been to try to factor it, and then when we had a bunch of factors, we set it equal to 0, and those were zeros. So in order to factor some things, we're getting to the point where it's not just a bunch of rules. It's actually, how can we figure this out without knowing the rule already? And we had a bunch of rules for squareds, but now we're into cubics. So this is one step harder. That's where the synthetic division comes in. So our goal is to have it factored. And then once it's factored, right, so one of them, let's say this is x minus 3. Then we would say x minus 3 equals 0. And we would find the 0, because of this 0, would be 3. So this is just a side example of what our goal is. But before we even know what to use for synthetic division, we have to make a list of possible zeros. And that list comes from the idea of, when we did factor before, we considered the factors of the constants. So we'd consider the factors of 1 and 3. And we consider the factors of the 2 in the front. And we did a lot of factoring like that. We called it factoring ax squared plus bx plus c. We used the factors of a and the factors of c to do it. Well, now that we're going to see some more difficult examples, we're going to need to make a list of possible zeros, use synthetic division to see what works, and then factor from there. So the possible zeros come from this idea. We're going to make a list. So this is a list of the factors of the constant. So -3 is the constant in this case. -3 does not have an x, so it's not a variable. It doesn't have a variable. It's always the same, so it's constant. And then we're also going to consider the factors of the leading coefficient. We would have done this if we factored a simple quadratic, but this is a more complicated version. And we made this list last year in Algebra 2, but we did it, really quickly, and we moved on. So let's revisit that idea. So first we're going to make a list of the factors of the constant. So that's going to be, so these are my possibilities. What are the factors of 3? There's just 2 of them. What are they? 1 and 3. So when we make our list, we're going to put a plus or minus with the 1 and a plus or minus with the 3. Because it could be either sign, I don't know yet. And then I'm going to consider the possibilities of 2. So 2 only has 1 and 2. But my little equation here says for my list, I need the possibilities for the constant over each of these. So if you consider that this is like 1 over 1 and 3 over 1, those are your first things in the list. After that, I have to say 1 and 3 over 2. So I need plus or minus 1 over 2 and plus or minus 3 over 2. So on top, these are from the constant term. And on the bottom, these are from the leading coefficient. And that's what we're going to do every time. So for this example, how this is helpful. I've got sort of notes mixed in with how we're going to work the problem, but this would be really difficult with guess and check. Okay, it'd be just too hard. So what we're going to do is we're going to narrow down our choices with this list. Normally we start with 1 and -1. And a lot of times, a whole lot of times, one of those will work. So let's see. Let's try, what do you want to try? 1 or -1? -1. Okay, so -1 in my polynomial right here. So 2, 5, -4, and -3. So you try it, see if it works. Give it a shot. I don't think it does. Maybe it does. Let's see. 2, -2. 3, -3, -7, 7. Okay, that doesn't work. So we just put a line through it and go, well, let's try 1. So that'll be 2, 5, -4, -3, but now we try 1. And we got 0, and I put 0 on mine. So if it goes in evenly, it's a factor, right? So like 20. 5 is a factor of 20 because 5 goes into 20 4 times without remainder. 2 is a factor of 20 because it goes in without remainder. 1 is a factor of this polynomial. In other words, not just 1, but x minus 1. When we write it as a factor, we change the signs. So x minus 1 is a factor of this polynomial because we divided it. This is synthetic division, it's division. We divided the polynomial by this factor and we got 0 remainder. Just like 4 goes into 20, oh I used 5 a minute ago, and gives you 5 with 0 remainder. So 5 and 4 are both factors. So what do we do now? We take what we did from yesterday and we rewrite this part as a polynomial. This is 0 remainder, so no fraction. This is the constant. This has an x, and this has an x squared. So now we have left over 2x squared plus 7x plus 3. We've started the factoring process. We found one that worked. Yay. We now have something else we could factor. This is a squared, so we might be able to just think through it and factor it. We could do synthetic division again, but look at the number of choices I have. That's a lot of them. So instead, let's give it a shot. What are the only factors of 2? 1 and 2. So let's do 2x times x. That's it, right? The only factors of 3 are 1 and 3. So it's either 1 and 3 or 3 and 1. So it's easy for us to try it and see if it works or not. So which way do you want me to try it? Okay, so if I try 3 and 1, that gives me 2 plus 3. Is that 7? Okay, so let's try it the other way. 1 and 3, that would give us 6x plus 1x. 6x plus x is 7x. So look, now it's factored. So synthetic division said, okay, this is what you would want to try. These are the only rational numbers, meaning fractions, that would work.
So we only pull like from a -3 and the 2 from the ends from like the possibility.
So you don't, so just like 7, this 7x happened, it just happened because we used 2 and 3 as factors. We did not use factors of 7. We do not use factors of 5 and 4 because they're in the middle. They just happen. It's just the ends. And the constant is always the one on the top. Okay? So, because look, this is going to be, if you solve it, this is x equals 1. And then this one is 2x plus 1 equals 0. If you put the -1 on the other side, 2x equals -1, x equals -1/2. Is that one of my choices up here?
Yes.
Yes, but the 2 had to be on the bottom because the 2 goes with the 2 in the front. It has to be in that position. So we got 1, -1/2, and this one would be -3. So what did we do? We took a really hard problem to factor. We used a trick to figure out what to try. We might write this small because we might have to try 2 or 3 things until we get one that works. But synthetic division is quick. You know, it's not the long division problem. So, and then when you get one that works, usually after that it factors. Or you could try more problems. You want to try another one? Yes, good answer. Okay. All right, so another one. Let's try g of x equals 27x to the 4th minus 9x cubed minus 33x squared minus x minus 4. This is a 4th degree polynomial. It should have 4 little groups of factors. I can't guess what they are, but I can make a list. You start with a list. Put the constant values on top, so all of the factors of 4, and then the factors of 27 on the bottom. That's your fraction. So make your list. I'm going to ask you for that list. You need to be able to make that list on your own. So plus or minus 1, 2, and 4. Then I'm going to say plus or minus 1 over 3. This has 1, 3, 9, and 27. That's got a lot. So I'm going to have plus or minus 1 over 3. Plus or minus 2 over 3. Plus or minus 9 over 3. And plus or minus, oops, I went crazy. That's supposed to be 4 over 3. So this should be 1, 2, and 4. 4, 3. There. Then I do 9. Plus or minus 1 over 9. Plus or minus 2 over 9. Plus or minus 4 over 9. So this is all over 1, this is over 3, this is over 9, and then I have to do 27. Am I going to do all of these with synthetic division? No, I'm not. But these are the only possibilities for real number solutions that I have that aren't like irrational. 2 over 27 and 4 over 27. But usually 1 or negative 1 works. So let's try 1. 4, 3, 2, 1. I have all of them listed so I don't have to put any zeros to hold places. That's really important. So 27, negative 9, negative 33, negative 1, and negative 4. So Jack, help me out. Since you're not writing, you can just work out loud. So 27, then what? Okay. 18? Yeah. And it's positive, okay. So 28 plus 5, 15? Negative 15. 15, negative 16. And then, so no. Well, that's too bad. Let's try negative 1. 27, negative 9. And you can write these little on your paper. I'm writing them big because they're up here on the board and stuff. If it was my work for my whatever, I'd write them really little. So 27, negative 27. Negative 36, yeah? Positive 36.
Wait, would it be? Oh no, you're right.
Okay, and then negative, and then add, and then multiply by negative, so it's positive, so we get 3.
Yeah.
And then multiply negative 3, so we get negative 4 times the negative is now positive 4, so we got 1. So when you do this, I want you to go ahead and take this and write it as x plus 1. When you put it in factored form, it's opposite math. And then write this over again. 27x to the third, a degree less, minus 36x squared plus 3x minus 4. Now you're dividing into this. And the ones that I want you to try, usually 1 and -1 work. I think the list is short for tonight. The first few are just writing them out. Then you've got to try and try again. So the next one, because we're pressed for time, it's 3 o'clock. 4/3 works. But keep in mind, I'm going to give you some hints to look at so that you won't spend all day, because this is a ton of zeros. So I will give you some sort of hint to get through. One of them will probably start with 1 or -1. And if one of them doesn't work, I don't feel bad about it. But I don't want you to have to go through 9 iterations before you find another one that works. But if 4/3 is going to go into it, I'm going to use the simplified version. I'm not going to start with the one at the top. I've already factored it down a little bit. So I'm going to use this one. And then when I multiply, it's not that bad actually, because 3 goes into 27. That leaves me with 4/3 times 27 is 36, right? So that makes 0. 0 times anything is 0. Now I have 3, so 4/3 times 3, that's not bad. That's 4, and that's 0. So that worked. So now I have x plus 1 from the first one. I have x minus 4/3. And this is left over. This is the constant. This is x, and this is x squared. So 27x squared plus 3. Oh, yeah, plus 3. That would factor again just a little bit, because I could take out the 3, but that doesn't help me because I still have x squared plus 3. That doesn't factor. So you could set each of these equal to 0. We would get x equals -1, 4/3, and then 27x squared equals -3 when you put it on the other side. So x squared equals -1/9, and there's no square root of a negative number. This is about real numbers, so we would stop here. These are the only real ones, because this is imaginary. Has a negative there. So when you get anything negative, you can stop.